All right, good morning. Welcome. I hope you guys are enjoying the conference. It's been pretty exciting to be here. Uh, Thanks for attending the session. So, hi, I'm Prasad. I'm co-founder and CTO of Okahu AI. I'm also part of the steering committee of Project Monocle, which is a open source project under Linux Foundation's Data and AI umbrella. So today I'll be talking about monitoring GenAI applications. Let's look at the agenda. We'll briefly look at what application patterns are there for GenAI, this whole new ecosystem that has come up and becoming so popular and so hyped. A few examples. I have a agentic tool that I'll show just how a representative example of GenAI application. And then we'll talk about what is monitoring and why it is different than the traditional application monitoring that we been doing that for such a long time. I'll talk about the Project Monocle, which we started late last year under Linux Foundation Data and AI. Do a demo of how easy it is to add Monocle to your application and how to get the traces out of it. What does the trace meta model look like? And then beyond just collecting the traces, how do you then go and make use of it to find out what's going on with your application and improve it? Okay, so the GenAI application. So what we have seen over years that there are these 2 or 3 typical design patterns. You have copilots, which helps you, an existing application assist do the task. You have conversational chatbots, which has been the early part of it, do question and answer. And then the whole exciting world of the agentic workflows where it goes beyond a chatbot and you can actually make it actionable by integration of these tools and agents. And then on the other hand, you have all these different technology components that are used to building this application. You have the application coding frameworks and libraries like LangChain and Llama Index, or your OpenAI agentic tool, the Google Agent SDK. And then you have all the LLM providers and LLM hosting. You have your Azure OpenAI, Bedrock, and OpenAI, etc. And all these applications and often these LLMs are then hosted on different public clouds like AWS and Azure and Google. So most applications are using some of these libraries, some of these LLMs, and then being hosted on either public clouds or sometimes on a private cloud. So I'll show an example, a demo agent. Okay, sorry. Is it readable? Okay, so this is a travel booking agent. There's a supervisor travel agent. It has a bunch of worker agents, which does the hotel booking and flight booking and the summary of your tour of the booking. Each of the agent has a tool to do the task. And then there is the coordination. This is using the Google Agentic SDK toolkit. So let's run this. Okay, so I've just saved the user request to avoid delays. So let's paste this. So it's saying, book a flight from San Francisco to Mumbai on this date and, book a room at this hotel. So just run this. It said, oh, it done some work and gave me a status back saying my flight is booked. Little iffy, it's not telling me, whether my hotel room is booked or not. If I look at my code, the beauty of and the bit of a curse of this is that as opposed to a traditional code, a lot of your code here is really your prompts and your instruction and your descriptions rather than the individual instructions. So to see what is the problem, what's working or not working, is really the tools that you have is to tweak your prompts or change your model or change your context. So to find out what's going on under the cover, like what decisions your, let's say, the agentic toolkit is making to decide which tools to invoke, which agent to delegate to, which tool, what parameters to be invoked, is all depending on these prompts and description that you are providing. And that's the very non-deterministic nature of all the Gen AI applications, which is what makes the monitoring really complicated. So let's talk about that, right? Just to more segue into that. There are so many new technology components that have come out of this. You have your LLM providers, the language frameworks, your vector databases for your RAG patterns, where a lot of your context is sitting in an outside vector store, and then you, on demand, extract that context and give it all to the LLM to get the answer back. The non-deterministic nature of the LLM is the biggest challenge to deal with in all agentic application. If you have written the code, you have written a specific integration test, you know very well how that code is going to perform. But here you have the same prompt given to the same LLM. There's not a guarantee that the same answer will come back. And then you leverage that further into the agentic framework. Is that answer then gets interpreted to decide what agent to call and what tools to call, make the thing really complicated. And of course, the evolving ecosystem, like every other day you will find some new framework coming out, new models coming out, new hosting providers coming out. So as you decide that this other choice is better than me, your application is going to continue to evolve. And then whatever you have done for monitoring or tracing that application needs to cope up with that evolution, which also makes this thing really hard. In fact, it's not very uncommon that in your development cycle itself, you've gone through 2 or 3 different choices of models and language frameworks, etc. So what you started off with your logging, or a lot of your custom logging, probably wouldn't work to the next level of your, your monitoring choice tool. So then let me introduce Project Monocle. This is an open source project under Linux Foundation Data and AI umbrella that we introduced last year. It's a community-driven open source project. The objective is to do an instrumentation of your GenAI application so that you can get a peek inside the libraries that you're using, not necessarily just your code, which of course you can with the custom instrumentation, but it helps you understand the underlying GenAI components that you're using. What are they doing? What agents are they calling it? Why are they calling it? What prompts are getting sent? What the token information is coming out? How long each of the stage is taking? And all that in a consistent format across different frameworks. Whether you're using LangChain or Llama Index or using Google ADK, you want to look at a consistent format of that trace. So whether you are manually analyzing it or using some other OTel compatible tools to do analysis, that rest of your machinery can remain the same, and Monocle is doing all the heavy lifting of understanding those libraries, understanding their APIs, and give you a consistent picture of what's happening under the cover. This is built sort of on top of OpenTelemetry, so it uses the OpenTelemetry compatible spans. So if you're using an existing observability infrastructure, you have, let's say, you're pushing your traces to, say, Grafana and doing some analysis. Most of that machinery will work as is. Of course, there's new information that's coming in, so you need to build a way to analyze that new information, but it's fully compatible with that format. Okay, so let me show you a quick demo of that same agent what I showed. How do I add Monocle to it? How do I get a trace? And how do I make a sense out of it? So let's go back to that same application. So one of the focus we have is to make this as developer friendly as possible. So we have built Visual Studio extensions. So for example, I have a Monocle extension here that just lets me, sorry, wrong choice. It says enable Monocle for Python. That's the right project. So this is my agent. So I choose the Monocle extension, which I've already installed on this. It says enable Monocle for Python. And it just added these 2 lines here. That imports this library. And this makes a single API call that's a setup telemetry. OK, so I'm going to run this application again this time. Okay, sorry. Hope it's still readable. Run the same application, and I'm going to pass the same prompt or the user request here. So I got a response back. Actually, let's see, instead of a console, I'm going to send this to a file so I can show you this better. So let's rerun this. Okay, and so under my .monocle folder, it has created a trace file. And this is an OTel compatible format file, and every operation that this agent did under the cover, like all the inference calls, the agent invocation, the agent delegation, etc., are captured in the OTel compatible format. So if you guys are familiar with OTel, this is the standard OTel header that says, what is the name of the span, its trace ID, span ID, etc. And then the details here are specific to Monocle related to your GenAI application. Like, what was the type of, it's an agent routing, what was the name of the agent, and then, what was the prompt pass, what was the response captured, etc. So you get to see all of that. And then the Monocle distribution now includes a MCP server that comes with a set of prompts that help you analyze this. And this is great for machine analytics when you have the JSON that you can put it in a relational or non-relational schema and query this. But at the early stage of the project, as a developer, when you're running, let's say, your integration test, your regression test, and you want to see this trace file and see what it is, there is a simple analysis prompt that is part of the MCP, which I've already installed in my Visual Studio. So this one is called analysis. So let's run this. It's running using the Visual Studio Copilot. So it has picked up this local file, and it's running, I think I'm using the Sonnet model here. So interestingly, okay, let's go back to summary. It actually says that error detected malform tool call and output truncation. Okay, so it's saying there was a max token error, so let's go find out. Okay. So let me go back to my code. I don't want to see a token error that's truncating my output and running, messing up things. So I have set up token, just for this demo sake to, I want to save money, don't want to spend too many tokens. So that's what I have set a lower token limit, and that's now kind of causing a problem for me. So let me reset this and see if my agents start behaving better with this. So I'll make it something like 50. Let's run this again. Take this request and run this. Okay. I think we got a better response. It told me that it has booked the flight and the hotel. And if I go back to my new trace, now this time, let's see if there's a token error. Okay, it's still there for 50. So, but I think you get an idea that it's sort of pinpointing you where the problems are, and then you can iterate in your development cycle to resolve them. And this time maybe I'll bump it up to 100 and see if that helps. So once I'm ready with my test cases, that's when then I'll go and publish this to my prod. I can leave my trace collection in place. So as my pre-prod or my prod, when my application is running, I'll continue to generate those traces. And if there is a problem later, I have a full visibility of what happened in that problem case. Then I can go back, bring this back into my dev environment, analyze it, and see where the problem could be. So just a quick summary of what Monocle is. As I said, it's a OTel spec compatible library. We distribute Python and TypeScript, so whether you're building your application in either of those languages, you can get benefit of this. It's a community-driven open source project. We really want people from the language framework vendors or the LLM vendors to be participating so we can formalize that spec better as the things evolve. So it's not proprietary to a a vendor who's driving this hotel product, but a community-driven effort, so all the vendors and all the consumers will be benefited out of it. And that's, again, one of the reasons why Monocle, as being a community open source project, the goal is to generate this consistent standard format for all the GenAI application. The Monocle community will continue to work in collaboration with others to make sure all the popular new frameworks or libraries that come in, they are covered by Monocle, and you see the same consistent format. As I said, there's very little code change that you need to do. Of course, you do want to extend this to do your own custom code tracing. It's very easily extensible. You can generate your custom span for your own code, or there's a proprietary library that you are using that's not in the open source for Monocle community to build. You can always extend it yourself. And once the traces are generated, you can they are by default go in a local file, but you can always send them to a cloud store. Again, there's an out-of-the-box support. You can put it in S3 or Blob Store. Or you can send it to a hotel collector, which then down the stream connected to your other analytic tools. I don't know if you guys attended the talk by Microsoft folks yesterday. They showed an example of taking some traces in Grafana and analyzing that for looking at prompts. So all those things will be possible, but they extract the traces that you are extracting. Just briefly on the Monocle concepts, it's very similar to OpenTelemetry, the traces and spans, the exporters that says how the data goes out. And the meta model is like what describes a Monocle's trace, what information it's collecting, and that's why it's consistent and standard. And finally, going beyond this trace generation is like, how do you analyze it? How do you store it? As I said, you can put it locally for your dev environment. You can store it in a cloud store for your pre-prod or prod. And then there are third-party products that you can use. We from Okahu AI has a product that's fully compatible with Monocle that we can ingest all the Monocle traces and provide a lot of insights on that. I can just quickly show that view. Like for example, this is a Microsoft Teams chatbot. And it's showing me like how many traces that came in, or like how many inference I ran on that, what prompts are collected. You can use a third-party eval tools, like there are open source project that helps you eval, or Okahu has an eval engine that tells you, what your prompts are and how they are evaluated, sentiment analysis of the prompts, etc. Like this one is, it has a negative sentiment on the conversation. You can also look at the architecture of the product based on all the trace information. It tells you what agent is calling what tool, what workflow. So you can build a graph like this that shows the architecture of your application, and as things evolve, you can see what changed at what point, and then how it impacted your application's performance and views. So finally, my call for action, please check out Monocle. It's an open source. Try out a library, give us feedback. If you want to contribute, you're most welcome. It's a community-driven project. And you want to take the Monocle trace and see how you can do more with it, try the Okahu Cloud. You can always sign up. We have a freemium offering for an individual user. You can just sign up, create your tenant, and send your Monocle traces in there. So thank you very much. I think we still have about 5 minutes, so happy to take questions. Okay, yeah, please.
So one question. There's open inference, and there's also the GenAI updates for the semantic conventions at the moment for OpenTelemetry. In terms of the attributes defined in Monocle, where's the differentiation here? Which attributes are being defined that don't exist in the OTel GenAI specs at the moment, right, and which are not defined in open inference?
Okay, so I don't have a specific answer. I'll tell you why. I mean, when we started, I think the OTel project, the semantic convention for GenAI, I think, was in the early stage. But I would say our conviction is that the AI-specific spec, not the OTel frame, but the underlying details, kind of should belong in an AI project than a OTel project itself, the way the things are evolving. That's one of the reasons we started off this as a separate project, and we want to keep the spec here. It's something that's on my plate to go back and do this comparison and see if we can have a combined one rather than 2 copies. We would still prefer to keep it in the data and AI land rather than the hotel land, but at least we'll put an effort from our side to see if the hotel community decide to continue on that, and if there's a difference, then at least we should be a compatible or superset of that. So do you have was there another part of the question that I missed? Or?
No, you answered it.
Okay, yeah, thank you. Sorry, yeah, go ahead, please.
Yep. So thank you for the talk. And from the point of view of security, especially when using guardrail engines such as LLM Guard or guardrail AI or whatever like that, do you also get visibility of that part? Like assuming you have guardrails within your agent, can you see on the traces when something was caught by a guardrail, like blocked or just?
Yes. So in most of the cases, let's say we have tested with say Azure OpenAI. So if there is a guardrail, you set it on the Azure OpenAI level.
No, I mean because there are some engines you can incorporate within your agent. So
Oh, within the agent itself. Oh, I see. Okay, so the Monocle project itself is not doing anything specific. It's capturing all the information that's going back and forth. Okay. There is no specific feature that's currently implemented that applies the guardrail. Now that said, there's nothing stops us somebody from taking that information and building it. But out of the box, that support is not there. As I said, the current goal is to build a visibility layer that captures everything. Now, what you do with that captured information, or if you want to do something before that information is sent out, it's possible, but it's not currently implemented. And it's a good feedback that we'll keep it on our roadmap as well.
thank you.
Any other questions? Okay, cool. Thank you very much. I appreciate your time.